Hi, James. I want to talk about in detail how the machine does the simulation and make its prediction more and more precise. The parameter that the machine uses to decide if the simulation is good or bad is called loss function. And it's basically to measure the distance between the predicted data and the actual data. So the actual data are here. Well, for each x1, x2, x3, it has its actual values, y values of y1, y2, and y3. And if we had a prediction, something like this, we have the corresponding predicted value. Y hat 1, y hat 2, and y hat 3. I want to know how far away each data pairs are. Say the distance between y1 and y1 hat, and the distance between y2 and y2 hat, and distance between y3 and y3 hat. And when we talk about difference, we don't care about the positive or negative values. That means as long as the value is far away from 0, we think the distance is high. And to make the calculation easier, we use the square to turn all the negative values to positive values. So that's what the loss function is. For this loss function, we have y hat 1 minus y1 square plus y hat 2 minus y hat square, y3 minus y3 square. And then we get them all and divide them with 2m. M means the number of the samples. In this case, m equals 3. And this is our definition of loss. The bigger the loss, the worse the prediction is. The smaller loss, the better the prediction is. So our goal is to achieve the smallest loss as small as possible. To do that, we want to treat these two values, W0 and W1. And by changing these values, we can make the y hat values go up or go down. And usually it's hard to deal with two variables at a time, so let's fix one variable and focus on one variable. In this case, let's fix W1 fixed. We don't want to change how the line is tilted, but we want to change how the line moves up and down, since it's easier to do. So if we fix W1 and change W2, it'll go something like this. If we increase W0, the line will move up. And if we decrease W0, the line will move down. That's how this W0 do. And we can see from here, starting from here, the loss is pretty big. But if we move up here, the loss is much smaller and probably gets to its minimum value. But if we keep moving up, the loss goes up again, which means we are again far away from the actual value. So if we plot it on the diagram, we will see something like this. So this is a loss, and this is W0. So if let's see, if it is small, the W0 is small, then the loss can be pretty huge, which means the line may be sitting somewhere here. So it starts from here. But as W0 goes up, that means the line is approaching the ideal line closer and closer and closer. The loss goes down dramatically. Great. Now it hits the sweet point, which means that's minimum. And if it keeps going up, then again the loss will go up. That's what it is. And if we can get the minimum point, then we're done. Well, for W0. And it's also true if we change W0 to W1. That means we fix W2 and we tilter the line this way or that way. If we increase W1, then the line will go like this. If we decrease W1, then the line will go like this. Anyway, the loss function, no, not the loss function, this curve will look similar. It will have a minimum value at some point, and either beyond that value or less than that value, the loss will be changed and will increase. So if we can plot both W0 and W1 on the same diagram, say, first is, okay, I'll just stop. Right, okay. Say this is W1, then we may see something like this. It's a curved plate, and somewhere here we hit this very sweet spot where the loss function is a minimum, and that's where we call it the converge. So what we're doing is we usually start on this plate from a random site. In this case, W1 equals 0 and W0 equals 0. Maybe, no, not here. Must be, loss function must be somewhere here. And we start trying to go to the sweet point. And the way we do it is we calculate the partial deviation of W0 and W1 and take a small step there, and we may move down here. After we move down here, we'll look around and decide which direction we should go. So we make small steps, little by little, until we're pretty close to this sweet spot. And if we want to make huge leap rather than small steps, we may end up doing something like this. We still start from here and we make very big leap here and here, and since we're leaping too much, we may miss this point and jump somewhere there, and we miss that. So the size of each step is crucial. If we move too slow, it may take us forever to get to the sweet point. And if we move too fast, we just miss it and it's lost in the outer space. And so the size of the step is called learning curve. Learning rate, and is alpha. I think in the farm learning they use alpha to mention it. So this is basically the whole idea of machine learning. I think if you get everything I mentioned here, it should not be a problem that you do your assignment. Yeah, that's it.